Hello, everyone. This is Module 7, Day 2, and we're working with circles again, and this one's a lot of vocabulary, okay? So let's take a look here. First, vocabulary word, a chord. A chord is a segment whose endpoints are on the circle. So if I plot 2 points on the circle and I connect them, right, that there would be a chord. Okay. Now a tangent. A tangent is basically a segment, line, or ray that intersects a circle at one point. So if I plot a point on this circle and I draw a line through that, and that line intersects the circle at one point, right? Now, sometimes it may look in the diagram like it intersects at more than one point, but that's just the way it's drawn on paper. But you have to imagine that that line and that point only intersect the circle one time. Okay? And a secant is basically a line, right, that intersects a circle 2 times. So it goes through like this. This here would be a secant. So you have a chord. This is a tangent. And this is a secant. Okay? So when we look at example 1, right, if we had to name a radius in this diagram, a radius, remember, goes from the center, right, from the center to a point on the circle. So you actually have 2 here. You could either say CD, right, or you could say AC. Both of those are radii. Remember, you could also name this DC or this CA. It doesn't matter. Now, a diameter, remember, goes from one point on the circle to another point on the circle through the center. So that would be segment AD. Now, a chord. Yes, a diameter is a chord, but in this case, which line or segment gives me a chord? Well, if I look, HB is a segment whose endpoints are on the circle. So HB is a chord. And again, you can name that BH also. A secant, right, that would be JK, right? But because it's a line, I have to put the arrows on the end when I name it. And a tangent, what line intersects at one point? That would be GF. Now, that's line GF, but you could also name it GE, EG, FG. You can name it a lot of different things. Now, the point of tangency, right, is what point does this line intersect the circle at? That would be point F. All right. Now, the next definition is what we call central angle. A central angle is an angle whose vertex is at the center. So this here is a central angle. Okay. So I can say that angle CAD or angle DAC, doesn't matter which way you name it, right? But that there is a central angle. Now an arc, right, is a portion of the circle measured in degrees. So right here, this is what we call an arc. And what we do is we measure that arc in degrees. Now, the symbol for an arc is this here, and that goes above the 2 endpoints of the arc. Okay? So when I look at this, I would name that either arc CD or arc DC. Now, one thing you have to know is the measure of the arc is equal to the measure of the central angle. Okay? That's something very important to understand. So if this central angle was 70 degrees, that arc would measure 70 degrees. Okay? Now, there are 3 types of arcs we talk about. So the first one is a minor arc, right? This is an arc whose measure is less than 180 degrees. Okay? So when I look at this, right, when we talk about an arc whose measure is less than 80 degrees, we always name it using 2 points. So in this case, this arc here looks like it's less than 180 degrees. Therefore, we're going to say arc CD is a minor arc. Okay? Next, a major arc, right, is an arc whose measure is greater than 180 degrees. Okay, remember, a full circle is 360 degrees, right? A half circle is 180 degrees. So when we look at this, if I look right here, this arc would be considered a major arc. Okay, now we name a major arc using 3 points. And the reason we do this is when I say arc CD, I could go one of two ways. I can go the short way or I can go the long way. How do I know which way to go? Well, what I basically do is if it's named using 2 points, I go the short way. Named using 3 points, such as arc CED, that tells me that that's a major arc, which means I'm going to go the far distance. Okay? And then a semicircle is basically 180 degrees. Now this you can name using 2 points, right? I can name this either HG with the arc symbol above or arc HJG. Okay? And the reason is no matter what, this ends up being the same arc either way. Now remember, a semicircle, right? The endpoints of the diameter create a semicircle. Okay? So let's take a look here. Find the measure of arc DF. Since I know it's measured or named using 2 points, I know that that's going to be a minor arc. So if I had to go, I'm going to go ahead and go the short route. So if that central angle is 40 degrees, this arc is 40 degrees. So arc DF is equal to 40 degrees. Okay? Now find the measure of arc NML. This here is the major arc. So I know I'm going to go from N to M all the way around to L. But the thing is, I don't know the measure of that central angle. But if I know this central angle is 110, I know this minor arc is 110. And if I wanted to find this major arc, what do these two arcs have to add up to? Well, they have to add up to 360. So what is 360 minus 110? That would be 250. So this arc here is 250 degrees. So arc NML is equal to 250 degrees. Example 4, if I had to find the measure of arc or angle ACB, that's this angle here. Well, if that arc is 165, that central angle is 165, and we are done. Okay. Example 5, not much more difficult, right? But what I like to do is find the measure of all the arcs right away before I even answer any questions. So if that's 40 degrees, that's 40. If that's 80, that's 80. If this is 110, this is 110. So now to find this arc from G to F, I'm going to do 360 minus 40 minus 80 minus 110, right? And if I subtract those, so 360 minus 40 minus 80 minus 110, that would give me 130 degrees. Okay? So right away here, now GF, if I look from G to F, that's the minor arc, so that's 130 degrees. GE, now when I look at GE, that starts at G, goes to E, so GE is going to be 40 plus 80, which is 120 degrees. Now GFE, so I'm going to start at G, I'm going to go to F, and I'm going to go to E. right away I have to recognize that that is a major arc because it's named with 3 points. I'm going to basically do 130 plus 110, which is 240 degrees. And then right away, FH, F2H, that would be 130 plus 40, which is 170 degrees. If you notice, any angle or arc named with 2 points is 180 degrees or less. 3 points is 180 degrees or more. Okay, last example, AB here. Right away when I look at this, I'm going to find the measure of these central angles, then the measure of the arcs. So right away here, if I look, what do these two angles have to add up to? Those have to add up to 180 degrees, right? So if I do 180 minus 32, right, what does that give me? 148 degrees. Now, if that's 148 degrees, that arc is 148 degrees. Now here, what is this central angle going to be? 180 minus 58, right? So 180 minus 58 gives you 122 degrees. Now remember, angles are different than arcs. You have to keep that in mind, right? So right away here, this would be 122 degrees. Now, arc AB from here to here, how many degrees is that? Arc AB is going to be 148 degrees. A to B to C, if I look, I start here, I go all the way around to C, and if I look, A and C are the end points of the diameter, so that's 180 degrees. BD would be 32 plus 58, which is 90 degrees. BC is going to be 32 degrees. Angle COD, that's this angle here. Well, that's equal to the measure of the arc, so that's 58 degrees. And then C to D all the way to A, that's half a circle. So that's going to be 180 degrees. Okay, do me a favor, go ahead and attempt the homework and let me know if you have any questions.